Hello, pre-calc. Okay, so today we're going to step back a little bit and talk about inverses, and the reason we're going to do that next is because we talked about exponents. We did some problems on exponents, and the next topic are logarithms, and logarithms are inverses of exponential functions, and so that's why we need to go back and do the inverse section. So just a quick example of what an inverse is. If I were to make a chart of the number of times you took the SAT and the amount of money you spent, you'd have a function that would be like f of x is 43x. If you wanted to figure out how much it would cost you to take x SAT tests. The inverse of that function is where I gave you the amount that it costs, and then you use that to figure out how many times you've taken the test. So those are simple inverses. This is really multiplication, and then this one is division. They're inverses of each other. Okay, so let's say that I have a problem where I'm trying to find the inverse of y equals x cubed. Okay, the basic way to do that is to start with your original function, using y instead of f of x. We've already got this set up like this. Then we switch the x and the y. So I'm going to type x equals y to the third. Okay, so I've interchanged x and y, and then I just need to solve for y. So that's easy enough. I'm going to go up here. Since I want to get y by itself, I'm going to cube root both sides. When I find the cube root, oh, where is it? Okay, when I find the cube root of something cubed, that just makes the cube go away. So I end up with y equals the cube root of x. And then I can rewrite this as f of x equals the cube root of x. And I'm done. Okay, so if you look at this in red, I've got y equals x cubed. And in blue, I have y equals the cube root of x. So those are inverses of each other. And what's true is whenever you have inverses of each other, two functions that are inverses of each other, they're always going to reflect over the line y equals x. So if you get stuck, a really good way to kind of find your way back, figure out if you're on the right track, is just to reverse the x and y values. So if I look at this point right here, let me get something here, then I'm going to have the point, this is 2, 8. Okay, that's the point 2, 8 there in red. Okay, so that means I can go down here to the blue function. I should be able to see the function, the point 8, 2. Oops, I didn't want to put that there. Okay, I retyped it. So this is the point 8, 2, so 8, 2 corresponds. I can do the same thing down here. You'll notice this is the point -1, -1. But that's fine because when I swap the x and y, since they're both the same number, I get the same point. And so you'll see sometimes the inverse functions cross over each other. Okay? 0, 0, same thing happens. 1, 1, same thing happens. Okay, out here you'll notice I've got the point -8, 2, -8, -2, and so I've got -2, -8 down here. But I've just got x, y values that are swapped. Okay, so let's say that I want to find the inverse given this function here. This is not too hard to do. I'm going to, first of all, change this f of x into a y. So here I'm going to just cross this out and make this simple. Okay. And then I ultimately want to swap the x's and y's. So this is going to become an x. These two will become y's. All right, so I'll pause for a second right there. Okay, so I'm going to go ahead and write, all right, got x times y minus 2 equals 1 times y plus 3. Okay, and then I'm just ultimately trying to get y by itself. So I'm going to distribute xy minus 2x equals y plus 3. Okay, still trying to get y by itself, so I'm going to get all the y's on the left and all the x's on and everything else on the right. That's easy enough. So I've got this xy minus y equals 2x plus 3. And now I've got to figure out how to get y's by itself. I'm going to factor the y out here. So I've got y times x minus 1 equals 2x plus 3. And I'm almost there. I've almost got y isolated. Now I'm just going to divide by x minus 1 here, divide by x minus 1 there, and I'm done. Okay, so I can cancel the x minus 1s, and I'm left with my inverse function, which is this. Okay, f inverse of x equals this mess here. Okay, so you may remember from last year talking about one-to-one functions. And a function's one-to-one if there's only one x that matches up with only one y. Okay, so three things have to happen in order for it to be one-to-one. First of all, it's got to pass the horizontal line test, and we'll talk about that in a minute, as opposed to the vertical line test. It's got to pass the horizontal. Its inverse has to be a function. And when I input or do a composite function of f of x and the inverse of each other, I should get x as a result, no matter what order I do it in. Okay, so let's do an example here. So if I look at this function right here, probably the easiest way to look at these graphs is say, all right, does it pass the horizontal line test? Okay, so this passes the vertical line test, right? I only go through one time, and that means that it is a function. But if I were to find the inverse, then I'm going to swap x's and y's, and that means I need to have it also pass the horizontal line test. Okay, so this does. I don't have any problem with that. So this is good. It's one-to-one. All right, now let's look at number 2. The problem with number 2 is that it doesn't pass this horizontal line test. So in other words, when I take this thing and try to find the inverse, I'm going to get something that is C-shaped. Whoops. And I can try a couple of points, and you'll see what I mean. If I look at the point 0, negative 4, I'm going to plot negative 4, 0 instead, right? On the new function here, I'll use a new color. Negative 4, 0. Okay, let's try another one. Let's say now that I plot the point, this one here is 4, 2. That means I need to plot the point 2, 4 on the inverse function. That's where it would fall. Okay. Now let's do the same thing here. If I have here the point negative 4, we'll call that 2. Okay, negative 4, 2, that means that I need to plot 2, negative 4. Okay, here's 2, negative 4. Now check this out. So far, I've got something that looks like this. See how this is not a function because it doesn't pass that vertical line test. I can input the number 2, and my calculator, if this were a calculator, would get confused. Do I spit out the number negative 4? Or do I spit out the number positive 4? That would be a terrible calculator if it would give you more than one answer like that. Okay, so this doesn't pass. The original function here in brown doesn't pass the horizontal line test, which means that its inverse will not pass the vertical line test, and so it is not one-to-one. This is a no. Okay, now let's look at the third one here. Okay, if I were to replace x's with y's, this function would be okay. And you'll notice I can put a horizontal line test anywhere I want. I only go through one point at a time, and so this function is going to be okay as well. Linear functions, never a problem. Those are going to be good in terms of having an inverse. Other than horizontal vertical lines, because vertical lines are not a function, but that's a special case. If I look at g of x, I think about, all right, what does that look like? That is an absolute value function. Again, does not pass that horizontal line test, so this is a no. Okay, not going to work. H of x in number 6 is another parabola. Okay, and you could be more specific in the way that you graph it, but bottom line is if it's a parabola, not going to pass the horizontal line test, so again, number 6 is a no. Okay, not one-to-one. So if we're going to say what its inverse is, what that means in either of these cases is we need to be very specific, give it a domain that'll make it so that it always works. We're going to talk about that in a minute. Okay, so verifying inverse functions, here's an example of how we could plug one into the other and show that it equals x. So that's another way to show. We got to have all three things work. Show that it is one-to-one. Okay, so if I want to have f of the inverse of x, I'm going to take this here. I'm going to plug that in everywhere that I have an x. Okay, so what I've done here is just tried to determine what is f of the inverse of x. Well, that means that I'm going to take this cube root of x minus 1, plug it in where the x is. So I'm going to see cube root of x minus 1, then plus 1. Notice that these are going to cancel, so I have the cube root of x cubed, which is just x. Okay? And the same thing will happen if I take this thing and plug it into cube root of x. Subtract 1, I will still just get x. So this function here is 1 to 1 because I can do a composite of the inverse and the original function and get x. Okay, so let's look at this one. Does this have an inverse function? Now, I have a specific domain here. So if I were to graph x minus 3 squared, okay, so I've got x minus 3 squared, the whole thing there. You can see that doesn't pass the horizontal line test, so it's not going to have an inverse function. However, what I haven't accounted for here is I only want this domain. So if I pull up a highlighter here, I'm only looking at anything where x is greater than 3. So you can see here, this part, if I just have this part of the function, that does pass the horizontal line test, and so then that will be okay. And I would say, yes, that this does. Only because I've got this domain where I want it to be. Okay, so let's look at this one. Now this one, it's a very similar to the last problem. All right, I want to know if this one is 1 to 1. So the first thing I do is just wherever I see an f of x, I'm going to put the letter y, and that's fine. Otherwise, it's just basically copied. Then I swap the x's and y's, which is, you'll see what I did there. The next thing I'm going to do is I'm going to try to get y by itself. So the way that I do that is I find the square root of both sides. So I'm finding the square root here, finding the square root here. But remember our rule, anytime you apply the square root, you need to think about the possibility of plus or minus x. So what I'm left with here is plus or minus the square root of x equals, now the square root of the square is just itself, equals y minus 4. So then just one last step, I have y equals square root of x plus or minus square root of x plus 4. Okay, so what I have here is y can either be positive x plus positive square root of x plus 4, or it could be negative square root of x plus 4. Now, if you had a calculator that said, well, your answer could be 40 or your answer could be 48, that would be very upsetting because we want to have one answer. Otherwise, it's not a function. So the way that this is written here, when I figure out what the inverse is not a function. Therefore, we would say it is not 1 to 1. This is not an inverse. I would have to first specify what I was talking about for a domain. And here I would probably say something like x has to be greater than or equal to 4, or x has to be less than or equal to 4, just so that I'm very clear. Okay, here are a couple of examples where you verify that one is the inverse of the other. We've already done one sort of like this. Let's just try this one. Okay, so I am going to put this 1 over x minus 1 everywhere that I see an x over here. So let me do that. Okay, so here's my f of x. Instead of writing the x, I'm going to write 1 over x minus 1. So you'll see where I did that. Replaced and replaced in yellow.